Here in Module 2.2, we are looking at a specific type of polynomial function. That you recall that we started our discussion of polynomial functions in Module 2.1. Now, a specific type of polynomial that is a quadratic function. A quadratic function is one that you are hopefully a little bit familiar with in the form ax squared plus bx plus c. It's a trinomial, sometimes factorable, but it doesn't have to be factorable. And the graph of a quadratic function is a U-shaped parabola. Hopefully some of these things are ringing a few bells here. Over the examples that we work in Module 2.2 class notes, we will see different forms, properties, a look at the graph, and equations of these quadratic functions. So let's start that here in question number 1, example number 1, where we are rewriting this quadratic function in standard form. So right now it's in the form ax squared plus bx plus c, the trinomial descending order form. Standard form looks like this. It's rewriting the function in the form a times x minus h squared plus k, where h and k represent the vertex of the parabola. You noted the vocabulary word vertex in your reading in your pre-class work for this module. It's just kind of the point right in the middle, the base of the parabola, that middle point on the parabola. If we're looking at the graph of a quadratic function, that's the vertex. And that's given by the point with x value h and y value k, the point h comma k. And what's nice about the standard form is that information of the vertex of the parabola is built into the form here, so that when you have it in standard form, you can read the vertex straight off of the function. And so if we're, say, graphing a quadratic function, it's very easy, a very simple matter to grab the vertex information from the equation, plug it into the graph, and get a good sketch of the graph of the function. Let's not jump ahead though. Here, the idea for this example is to rewrite from the form ax squared plus bx plus c, which is what we're given, to standard form, a times x minus h squared plus k. We already know a. A is the coefficient on the x squared term, the number in front of the x squared term. And if there's no number, that doesn't mean there is no a value. It means that that x squared term is being multiplied by 1. So our a value is 1 in this case. We still need to find h and k. That's the vertex. And as you noted in your reading, or maybe you even remember this from a previous math class, we have a relatively simple formula for finding h, that is the x value of the vertex. In the formula, h equals negative b over 2a. So negative b over 2 times a, where we already recognize that a is 1, and in this example, b is 2. So we've got negative 2 over 2 times 1, plugging in our value for b and our value for a into that formula, and reducing that fraction. We have negative 2 over 2, which is negative 1. So our h equals negative 1. Then we need to find k, the y value. So we just found the x value of the vertex. We need to find the y value of the vertex. And we don't need a special or fancy formula for finding the y value of the vertex. We find the y value just like we do any other y value if we're given the x value. If we're given, or if we know the input value, we know how to find the output value. We now have the input value, negative 1. We're going to input that into the function to find the output value. Here k is equal to g of h, meaning take the number that we just got for h, plug it back into the function, and get your output value. Simple as that. Of course, we need to make sure that we do the math right, but the idea is simple. Plug in the input and find the output. G of -1 then is -1 squared plus 2 times -1 minus 3, plugging -1 back into the G function. -1 squared is +1, 2 times -1 is -2, so 1 minus 2 is -1, minus 3 is -4. Make sure that you work the order of operations and do the math right there, but you should get an output value of -4, so that H is -1 and K is -4. Our vertex is the point -1, -4. Going back and answering the question, rewriting the quadratic function in standard form then, now we know A is 1, we know H is -1, and we know K is -4. Simply plugging those numbers into our form here gives us g of x equals 1 times x minus -1 squared plus -4. Then we can simplify a little bit, and we don't have to simplify completely here, but we can say, for example, anything times 1 is itself, so I don't have to write the 1 in front of the parentheses. We can also say that subtracting a negative, 2 negatives make a positive, so we can simply write that as x plus 1. And then similarly here, we don't have to write plus a -4, we can just write -4. This is what that looks like. I can simplify notationally down to g of x equals x plus 1 squared minus 4. And there's our standard form of the quadratic function. If you want to check and make sure that that's correct, FOIL it out, combine like terms, make sure that you get x squared plus 2x minus 3. You should, you will, and that's the right answer. Now we are looking at a different quadratic function, and we are determining whether this function has a minimum or a maximum value, and finding that value and finding the axis of symmetry. Determining whether the function has a minimum or maximum value comes down to remembering that the graph of this function is a U-shaped parabola, and a parabola, that U shape, is either going to open up or down, and we'll see examples of both as we go through the class notes here, but that determination is based on our leading coefficient, our value of A. Here we see that A equals 2. What's important is that that number is positive. That number is greater than 0. That tells me that we're going to open in the positive direction, that our parabola, our U shape, is going to be opening up instead of down. And so I have at the bottom of the graph a minimum value. So if I have a positive value for A, then I know my graph is going to open upward, and if my graph opens upward, then it's got a bottom point, it's got a minimum value. And that bottom point, that minimum point, is the vertex of the parabola. So if I'm asked to find that value, then I need to find the vertex. So let's do that. We know the vertex can be found using the formula h equals -b over 2a, where b is 10 and a is 2. So I've got -10 over 2 times 2. That's -10 over 4. That's -5 halves. And let's find the y value of the vertex by plugging the x value back into the function. So plug -5 halves back into the function to find your k value. That's 2 times -5 halves squared plus 10 times -5 halves plus 12. Do your math there. I'm not going to show every step of squaring and multiplying the fractions. In fact, I'll go ahead and just jump to the result, and if you have questions on how to get there, so make sure that you know the math of how to work all the fraction work and get the answer of -1/2 there. If you have questions, bring them to me in my live sessions or go check out the virtual tutoring lab and they can help you review your operations with fractions. But now I know that my vertex is h comma k, -5/2 comma -1/2. That's where my vertex is. And that means that my lowest point is at a y value of -1/2. My minimum value is -1/2. And then the axis of symmetry is the line, I'll sketch it here badly, the line that cuts my parabola right in half, the vertical line that slices the parabola into mirror images of the two branches. That's the symmetric aspect of this graph. That's the axis of symmetry. And it's a line that goes through the vertex. It's a vertical line that goes through the vertex. And that means a vertical line, as we know from the review module, a vertical line always has the form x equals a number. And what x will that be equal to? Well, it'll be equal to the x value of the vertex because it passes through the vertex. So the axis of symmetry is the vertical line equation, x equals -5/2.